Welcome back. Today we are furthering our discussion of transforming functions. We're going to focus on stretching and compressing. So the way that stretching works, let's take a look at our first example. So what's going to happen? So here right now we have the graph of y equals x squared. Okay, I've provided it for you. What we want to do is stretch it to become the graph of 2x squared. I want you to visually see what happens. But what ends up happening is every point is y value gets multiplied by 2. So this point right here has a y value of 4. So its new y value multiplied by 2 is going to be up at 8. This point right here has a y value of 1. It's going to get multiplied to now have a y value of 2. It's being pulled up. This one has a y value of 0, so it's actually not being stretched at all because 2 times 0 is still 0. This point right here, again, its y is being multiplied by 2, so it's being pulled up to the 2. This one right here, that is being multiplied by 2 as well, so it's being stretched up to the 8. So if you look at my new function, you can see what happens when you multiply by that vertical stretch. Okay, it's getting pulled up, it's rising faster. So that is what we call a vertical stretch of 2. All right. Oh, sorry, I spelled vertical wrong. Vertical stretch of 2. That's what we call that transformation, when there's something multiplying the function out front. Now, what about something like this? Okay, so this now, again, what we have at the moment is y equals x squared. What we want is y equals 1/2 x squared. So this time what's happening is instead of multiplying all the values by 2, this time we're multiplying them by 1/2. So what's going to happen? So right now we have a point up here at 9. It's going to be, again, multiplied by 1/2. So this time it's being scrunched down to 4.5. This point right here, that's being divided by 2 as well. That's being scrunched down to 2. This point right here is being scrunched down to 1/2. Again, 0 isn't going to change because 0 divided by 2 is still 0. That point on the right-hand side is being scrunched down to 1/2. The 4 is being pulled down to the 2. 9 is being pulled down to 4.5. So if you notice this time, this is what we call a vertical compression. So we call that a vertical compression of 2 because you're multiplying by a fraction. So you're actually pushing it down, you're compressing it downward. Okay, so graphically what you're going to notice is functions that have that kind of compression are basically getting kind of flattened out. So now let's start putting this all together, shall we? So let's talk about what we did yesterday and combine it with what we have today. So again, the two main things I want for you are the same. Can you describe transformations to me, and can you write a function based on transformations? So the first one, write an equation that vertically stretches a parent function, y equals absolute value of x, by a factor of 2, translated to the left 4, and up 9. That vertical stretch of 2. Okay, the vertical stretch of 2 is multiplying my function, multiplying my absolute value. Translating a 4 to the left. Okay, left and right happens within the function and is always the opposite of what you'd expect. Left is actually positive, and then the up 9 happens outside, okay? That's being added at the end. So you should be able to look at this and write that equation for me. Then can you describe transformations to me? So this 3, can you describe that that is a vertical stretch of 3? Can you see that x minus 5 and tell me that that's translated 5 to the right? Okay, because it always acts oppositely what you'd expect in there. The outside is translated, but it works the way it should, just 8 down. All right. So again, those are the 2 big things I'd like from you. If that makes sense to you, then you are going to be in very good shape as you work towards this next upcoming test. Let me just check. Nope, that is going to be all. All right, so again, please make sure that you have all this written down. Once you do, then move on and start working on your practice work for me.